Hey guys, we are in our free online coaching classes for the NET examination, and this video will be the lecture 6 on this series, and the topic is the radiation laws, and the book which I referred is the Climatology by John E. Oliver. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the heading. Actually, the Earth's atmosphere system is sustained by the supply of energy from the sun. The solar radiation is the ultimate source of energy that results in varied atmospheric conditions experienced on the Earth. To comprehend fully the role of solar energy in the function of atmosphere requires actual understanding of the radiation laws. And the following are some of the laws that governs the way in which the incoming solar radiation will react with the atmosphere as well as the surface of the Earth. So the very first law that governs the relation between the frequency, wavelength and the velocity, and according to which the product of the wavelength and the frequency of the wave is a constant which will be equal to the speed of the light. So C is equal to lambda by F, where lambda is the wavelength and F is the frequency and C is the speed of light, which is a constant, that is 3 into 10 power 10 centimeters per second. And this law indicates wavelength increases, frequency decreases. That is, the shorter the waves, they are characterized by the higher frequency, and longer the wave, that is characterized by lower frequency. Let me explain you the same law with a figure that you can see here. The very first image, that is the top one, shows the high frequency wave, and you can see the wavelength, that is the distance between the crust or trough and trough, which is actually smaller. And if you see here, this is a low frequency wave, and if you see the wavelength, that is the distance between crust and crust or trough and trough, which is comparatively higher. So this is the inverse relationship between the frequency and the wavelength, that you can see here. The higher the frequency, smaller the wavelength, lesser the frequency, that is bigger the wavelength. This is the very first law of the radiation. The next law, that is the Kirchhoff's law, states that the relation between the emissivity and the absorptivity of an object at a particular wavelength. You can understand that every object will be more absorbing at a particular radiation, but not in the other range. In the same way, the same object will emit a maximum amount of radiation at the particular radiation, right? So this is what he was explaining, that the alpha lambda is the fractional amount of energy that is absorbed at a given wavelength, while this epsilon lambda is the emissivity at that same wavelength. And this law shows the stronger the absorption of a radiation at a particular wavelength, also the stronger the emission of the wavelength at the particular same wavelength. That is, an object, if it absorbs a particular wavelength, say that is say 10 micrometer, then it will emit the maximum at the 10 micrometer. That is the relation between the absorption and the emission of a single body at a particular wavelength. And the next law is the Stephan-Boltzmann law, that is, the black body absorbs all incoming energy and radiation at the rate determined by the temperature. So the absorption is determined by the temperature. That is what he was saying, in which the radiation F is equal to sigma T power 4, where F is the flux of radiation, T is the temperature in degree Kelvin, and sigma is a constant. And this equation shows the flux of the energy from a black body is related to its temperature. That is, if the temperature rises, then the flux will be also increasing, right? And the next law is the Wien's law, which states the wavelength of a maximum radiation is inversely proportional to the absolute temperature. That is, the higher the temperature, the shorter the wavelength of the maximum radiation. So this law can be explained like lambda max is equal to 2897, which is a constant, by T, where T is the temperature in degree Kelvin. So from this we can understand, the higher the temperature, that is, they have the inverse relationship, right? So if the temperature is higher, then the wavelength will be shorter for the maximum emission. So after understanding these laws, we can understand one thing, that is, this is the range of radiation that is emitted by the sun. which starts from say 100 kilometer and ends with very small as much as 10 power minus 6 nanometer. On this broad range, a human eye can only view a shorter wavelength, say that is 400 nanometer to 700 nanometer, which is very small when compared to the very big range. And you can also understand the reason behind this. Let me explain with the previous law that we saw. Say here is the relation of lambda max and the surface temperature, which is by Wainwright. So the surface temperature of the sun is say 6000 Kelvin, and if you substitute the value of that, what you will get lambda max is equal to 0.48 micrometer, right? At the temperature of the sun's surface, the maximum radiation is in the range of say 0.54 to 0.7 micrometers, and this is precisely the range of radiation that the human eye perceives, and we call it the visible range. And this is a very good example of evolutionary process that the human eye have evolved to take maximum advantage of that part of the solar radiation that is in greatest abundance. Is that clear? Say for example, if you are in the space and you want to trace the earth, so what we can do is we can use the same formula for the earth. Let me explain you. Here is the formula that the surface temperature of the earth is say 288 Kelvin, and if you substitute this, you can find the answer that is the maximum where radiation is in the range of 10 micrometer. So if you are in the space and you are looking for the earth, you can use this wavelength to find the earth, because at this wavelength only the radiation of earth will be very high. Is that clear? So according to this law, whatever we read earlier, we can find any satellite or any planet. If you know the surface temperature, you can fix the band in which you can trace that planet or a satellite. Okay, I think this will be okay for you for this heading. And as mentioned earlier, I have created the WhatsApp group, and if you want to join that group, you can mail me your name, college name, and the class what you are doing, and your mobile number, so I can let you join in this WhatsApp group. And I have grouped my videos according to the category. So if you want to find any topic, you can just go and check the playlist. So they will be grouped according to the category it belongs. And you can connect with us by mail, Facebook, and Instagram, and these are the links for that. And you can also support us by like, share, and subscribe. Thanks for watching. Have a great day.